I'm Kanak. I'm with PIU since 3 years, last 3 years, and I'm having overall 10 years of experience in IBM field. Okay, so today we'll be discussing about the database and file system session 2. As all of you know that, or many of you know, we had one session on database and file system where we discussed about like physical file and source physical file. So today we'll continue with the remaining of that. We'll start from where we left on the last session. Okay, so let's get started. Today's agenda is we'll be learning about CHGPF and multi-member physical file and about RNN, and we'll move to logical file where we'll be learning about LF and its attributes with examples. So let's start with the CHGPF. Okay. So on last session, we saw that we can create one physical file using DDS. Okay, and that after creating that object, we can add data and see that data from that physical file. So let's take one example here. Suppose this is one PF. Yes, so this PF is having like DDS that considers item, date, sold amount, and these three fields. One is item, another one is date, another one is sold amount. So let me show you that the same on the print screen as well. This contains three fields: item, date, and sold amount. So let us see the data of this file as well. Okay, so these are the data: item name, sold date, and sold amount. So this contains day wise how many item were sold. Okay, so 22 and 23. Let's suppose you have created this physical file and you want to make some changes on the structure. As you know, once the object is created, if you make any changes on the source, that impact will be not be there on the object unless you compile it. Okay, it does not depend on the source anymore once the object is created. Now if someone wants to change the structure or add any new field, suppose as per the data we have this for length, like 9,000 is the maximum amount I put here. So as per the structure here, the length is 4 numeric digit. Okay, so let's suppose I want to make it 5, because if it is 4 I cannot enter more than 9,999. I want to enter, let's suppose, 10,000 amount. So in that case I need to make the changes here. So if I make the changes here, if I make it suppose 5 is 0, and I want to suppose add any new field here, I want to add something like how much stock is left in the inventory. So here I'll say remaining amount. Okay, so I have made this change, and suppose I want to add some key field as well. Okay, and to make the date as key field, and I want to make it as descent. So if we compile this source, I compile this. Okay, let me change this as well. If I compile this source, so what will happen? We'll lose the data, because you know, if we compile the source, if object is already present, it will first delete the object. After that, it will create a new object. So we'll lose the data. Once the object is deleted, the data will be lost. So without losing the data, if I want to implement the changes on the object, there is a way to do it using CHGPF. So this is the command for that, example of the command. So let's implement the same here. Let's take CHGPF. You can always take F4 here and on my library. And here there are some parameters we need to put here. Source file, that is, this is the source file of the source member. Okay, this is the library. And here another option is there for source member as well. Like you can specifically give the name, source member name here. So this source member will be referred to change the PF object, that is sold item is the PF object inside PIOINT file. It will refer to source member sold item inside QKNAKSRT source file inside PIOINT library. So once I hit the enter, it is showing that file sold item in library is changed. So let's see how the data is displayed right now, because I made some changes there. I increased the field length, I increased the key, I added one key field and also added one field. So now you can see one new field is added. As there was no data present, it has assigned default value. And how to know that field length is changed or not? Because previously it was 4s, I have made changes to make it 5s. So we can always see using DSP FFD on the particular object. So you can see here it is implemented. The length is increased to 5 and the new field is added. Okay. How to know key field is added or not? So in that case, there is one way using this same DSP FD, like DSP FD for field, DSP FD, you can check. Because there was no key. Right now you can see that number of key field is 1 and the key field is date and it is on descending order. So this way we are not losing the data, and but the renewed structure is implemented on the object. Okay, another point it was mentioned is if there is a chance of data loss, then CHGPF is not applicable. So suppose I have failed, like, let me check the data. Okay, so here you can see the field length is 4. I mean the data present is of 4 length. You can enter 5 length because the length is 5s0. So suppose I want to change this to make it like 3s. Okay, it is 5s, I want to make it 3s. So what will happen, there is already data present in the file using of 4 length, right? If I am decreasing the length, what will happen? Let us try to apply the same again, CHGPF. You can see that change of files will make us data to be lost. So it will not allow us to change it because data will be lost, because there are 4 length data. We are making it 3 length, so data will be lost. Okay. So this was for CHGPF. Next topic is member. I gave overview of this, a little bit of overview on the last session. So suppose you have one student file which contains this kind of data: roll number, first name, last name, gender, date of birth, address, contact number, only one student file. Okay, so let us consider this one. It is having data. So currently you want to implement this. This is for one generic one student. It is having roll number 1 2 3 4. Suppose this is for one single department. You want to implement this throughout the departments or throughout the, like, all the departments in your college or school. So for different departments, one way is to think of, like, we can create multiple physical files for different departments of electronics, information technology, chemical department, like this. We can create multiple PFs. But there is another way. We can create members using the same physical file. Inside the same physical file, we can have multiple members. Each member, we can rename it. We can rename the each member. Suppose for each department, one member will be electronics, one member will be information technology, one member will be like CSE, computer science. So like that way, we can uh, have same physical file with multiple members. Multiple member will contain different set of records, but they will refer to the same structure. When you say structure, it will refer to the same DDS, data description specification. So to implement this one, we do these steps. Like by default, when we create one object of a PF, it have it has only one member. Okay, the member name is default as the physical file object name. So if you want to create multiple members, as you mentioned, for different departments, if you want to create multiple members, these steps, you need to follow these steps. You need to increase the maximum number from one, maximum member number from one to as you require, like two members, three members, or you can mention there no max. That will implement, that will say the system that it can have the, multiple members, like um, for different departments. Okay, so after that we can add the member using add pfm, add physical file member, and we can give the name as department name, suppose ECE or CSE. So let's see one example here. Okay, so as we mentioned, like for student SF, there will be default member as file name. All right, so TSP update will show you the file details. Okay, and here also you can see that maximum member is set as 1. All right, so the first step is to increase the maximum member to the number you require. So for that we need to do CHGPF. The same way we implemented the change DDS to the object, same way we can change some attributes of the physical file using the CHGPF. So let's take CHGPF and PIO INT, and let's see the parameters. What all parameters are there? Okay, so here you can see max member is set as 1. Suppose I want to make it uh, 3 members or 5 members for my there are 5 departments in my university, so I want to make it 5. So I'm setting it as 5. So now you can see that it is changed. So same, we can check it using DSPFT student SF. Let's see what is source. So maximum member is 5. Right now there is only 1 member. Okay, so I want to add 1 member there. So you can use add PFM, add physical file member. Take F4 there. You can give the physical file name. You can give the library here, PIOINT. I want to add 1 member for IT department. I'm giving it IT. Okay, here for IT department. Okay, so member IT is added there. Okay, now if we check there, this PFD, you will see there will be 2 members. You can see 2 members are there. Okay, and we added only maximum member is 5. So you can see here max member 5 and 2 members are there. All right, so you can take this option, file name DSP to display physical file member. You can show here like the library name PIOINT. So you can see the physical file member. This is the first member. The member name is student SF. Okay, if you want to check the second member we gave as name IT, you can see that there is no data. So it shows the display physical file member. It shows the data of the particular member. And as you know, first member was named as the same as the physical file. We can always rename it. The command is to rename the member name is RNMM. So here for database file student SF PIOINT, previous name was student SF. I want to make it as ECE. So this name will be renamed. And if you want to check data one particular member here, you can check run query. Here you can give the file name student SF. Here you can give the member name ECE. You can see the data here of EC member. And if you want to check for IT, we did not add any data there. So you can see here, there is no data here. Okay, if you take UP DDTA to add the record there, as we learned on the last session, UPDD to add record. So update data, make the give the file name, library name, PIOINT, and you can give here IT. So a record will be added for this particular department. So for example, I'm giving one here and first name as last name, suppose Kumar, gender M, date of birth 20010506, address ABCD, and contact number, some random number I'm giving. Okay, this record is added. So right now, once the record is added, if I want to see that for IT, you can see only one record is there. And for ECE, you can see 4 records are there. So using single physical file, we can get multiple members like this way, and each member will contain different set of records that is mentioned here. To rename the member, you can use RNMM as we saw the example. And to remove one particular member, suppose I want to remove the record, I mean the member from the physical file RMBM. So if I take RMBM here, RMBM, that member will be removed from that physical file. So your file name, library name, member name, if you mention, so that member will be removed from here. All right, so let us try one example. Student F, PIUINT, I want to remove the IT from here. So member ID removed from file students F. So if you check right now, DSP FT or DSP, or you can check the data, you can try to check the data of IT, you will see that it does not exist. Member IT not in file. Okay. And if you want to check the data of EC, it is still there. So you can see that it is present. Okay. Another way is to clear the data CL or PFM. Clear PFM will clear physical file member. So if you want to clear the data or delete the data of a particular member, in that case, you can use CL or PFM. And if you give the member name here, student PF. So you can see by default it takes first member. If you mention the member name, it will show you that member of EC file student PF is created. It's cleared. So the data is deleted from there. So if you want to run this query, you will see that no data is there because all the records are cleared from that physical file. So this was about physical file member. Next, we'll move to RN concept. Okay. So RRN is nothing but what we call in SQL relative record number. So for each particular record inside the physical file, one number is associated with the record that is sequential. So once you insert the record, the first record is assigned as 1 RRN. The second record's RRN will be 2. Third record's RRN will be 3. So this way RRN is assigned with each record. So you can see it using update data or SQL RRL function. You can check what is the RRN of that particular physical file or table. So suppose let's consider this sold item physical file that we created and used CHGPF. So let's check this. So you can see UPDDTA with this sold item. If you check this, there are some records here. Okay. So these are the records inside this physical file, sold item. So as you check this using SQL, there is one SQL function to check the RRN as well. Select star from suppose sold item. We can mention the PIO INT library name here. So you can see here all the records are displayed. If you want to check the RRN particularly, we can give here RRN function RRN of sold item. So it will show you the RRN. If you want to select other fields as well, you can select from here using select RRN of this. Okay, I'll give some name to this physical file and I want to check all the data of this physical file. Okay, RRN of this column sold item. Okay, we'll select separately. Suppose item this. Now we can see that for each particular record, one RRN is associated with this. For first record was insert 1, 2, 3 this way. Okay. So what happens when we delete one record from this file? Suppose I want to delete one particular record from this physical file. Okay. So using update data we can delete, or using SQL also we can delete. So let's try one SQL function. Delete from PIOINT sold item, and we'll check where RRN of sold item. All right, equals to 7. Okay, one row is deleted. If you want to check this, you can see that the 7th RRN is deleted. So what will happen when we insert one new record to this? Okay, so let's see what happens. I'm adding one new record, suppose using UPDDTA and this. All right, I'm taking F10 here and sold at 202406. Sorry, 20. Let's add today's date 23. I'll add some other item here. Item name, suppose pencil, or you can pencil was already there. Suppose we are selling box of 500 amount, remaining amount is 200. Let's see what happens. The record is added there. Okay, so let's see what is the RN of this. You can see that the RRN is as 9. We deleted one record, still it is like whatever is the maximum value of the RRN, it is increasing with 1. So if it was 8, it will add us as 9. So to understand more of this, let's delete some more records. Okay, it is suppose greater than 5. So 3 rows are deleted. All right, then we'll add some records here. Let's see what happens. 20240923. We'll add some box here, and sold amount is like 600. Like this we have added. So you can see that the previous records were deleted. Okay. Okay, from greater than 5, all records are deleted. Whenever the new record was inserted, it is taking as 10. It will not add as RRN 6 because all those records were that spaces are occupied there in the system that is used later for different purposes. So it will keep increasing. The RRN number will keep increasing unless, here we mentioned here, unless we reuse DLT function there, reuse DLT parameter as star yes, when we create the create a physical file using CHGPF or make changes to the physical file using CHGPF. In that case, there is one option, reuse deleted, this reuse deleted space. In that case, it will reuse that. So once we, let's check this on the CHGPF. or create PF. There is one option. Okay, to give student and to give suppose sold item is the CHGPF sold item. Okay, and here you can see there is one option reuse DLT. If you make it yes, once you enter the next record, inside one next record, it will start using the deleted space, deleted RRNs that was deleted. In this case, from 6th to 9th, those RRNs are still, the spaces are available, but the records are not getting occupied. Once we insert the record, if you make it yes, in that case, it will start using those unused spaces. Another concept is to reorganize the physical file member. Using this command, we can reorganize that space. Like we can do multiple things using this reorganize PFM. One use is like we can reuse the space that was deleted. So what will happen? Let's see. We saw that the RRN of this was 1, 2, 4, 3, 4, 5 and 6, 7, 9 is occupied. 6, 7, 8, 9. There is no data, but still the space is occupied. So 10th is the next RRN. So once you mention here RGZPFM, if you mention this and for a particular PF for this, by default member is first because this is only single member physical file. So if you give here library name, it is reorganized. So let's see what happened to the RRN. You can see that the 10th RRN is moved to 6th RRN. Those blank spaces were cleared and the file is reorganized. All the blank spaces will be cleared and the RRN will be reorganized based on the available spaces. So this is the concept of reorganized physical file member. All right, we'll move to the next topic, that is logical file. Okay, logical file, as you know, this is also our object type star file because on last session we mentioned that all the database file in IBM system that will be of star file and the attribute is LF. So when we create one physical file, attribute is PF. So for source physical file it is SSCPF, for logical file it is LF. So the uses of logical file is like creating one view of that physical file. You have one physical already created, you created one physical file, you have some key field mentioned there, or you already have added some constants there. You want to add some more constants to this. Suppose every time you change the physical file DDS, you need to make CHGPF every time, or in some cases if data can be lost, you need to make you need to compile that physical file, you need to copy that data somewhere, so and so on. So to ease it, we can like create logical files that will be based on that particular physical file, and it will add some additional constants to that physical file. Okay, so it will contain the information to which PF it should refer and other information, like if I'm adding some new key field to I want to see the data or insert the data based on some new key fields, or I want to suppose see the data in some different manner. Okay, let me give you some example of that so that you will understand. Suppose this is my physical file. I'll show you the data. Select star from students. Okay, I'm having this data. All right, so I want to right now this students file. Let us check what is the key field of this. Maybe we have DDS of it. We can directly check there if we have DDS. So the DDS is having the key field of roll number. All right, so based on roll number, it is a unique field. So So this constraint is added to the physical files, that all the roll number that you are inserting in the physical file should be unique, and it will be arranged, the data will be arranged in key field manner. Okay, so let us check using UPDDTA students. So you can see that based on the roll number, it is displayed, right? 1, 2, 3, 4, 5, like this. So based on the roll number, this file is displayed. Suppose you want to make, you want to see the data based on the first name, all right? So, or some other name. It is currently based on roll number. I want to see the data based on first name basis. So we cannot implement here the another key, because composite key, if we add the composite key, the structure will be changed. We wanted to make it unique for the first key. So the solution for that is we will create one another LF that will be referring to this PF, and that will have only single key field, that will be first name. So that way we can see the data. If we retrieve the data, or we want to do the update data on that LF, so that will show us the data based on the first name order. All right. Or if you want to make some composite key unique, suppose I want to make roll number, and or maybe I want to make the phone number unique. In that case, I'll create another PF. I'll make the key field as phone number, and I'll make that unique. So let's see example of this. So I have created this LF. We'll learn about the DDS, but I'll show you the example that for in this LF, I have mentioned the key field as first name. So if we create this LF, the record will be arranged in first name order. We'll see the example when we'll see create the DDS. We'll learn more about this. And another thing we can do it, like we can here, as we mentioned, we can filter out the data by using select omit keyword, or we can concat two fields. Suppose in this physical file we have first name and last name separately. We can concat these two fields to make it a single name, and we want to arrange the field in different order. Suppose I want to see the first name first, then roll number, then last name, like this. So we can arrange that in the logical file. Okay, so these all things we can do. We can create union of two physical files, or we can create join of two physical files to see the data. We can only select only two or three fields. Okay, so suppose your physical file is having 100 fields, I want to display only 5 fields, so I can create one LF using only 5 fields of that PF. By referring that PF, only 5 fields will be displayed for that LF. So to create this logical file, we follow the DDS structure. Okay, we'll move to that. There are two kind of logical files. All right, one is non-join logical file, another one is join logical file. Non-join logical file is like when you are referring to one physical file. It can be one or more physical file, but you are not combining it based on any common field. Okay, you are just referring that physical file to get the data from that physical file, or to display the data from that physical file. That will be called a non-join physical file. It can have multiple record formats or one record formats. When we say multiple record formats, maybe you remember that for physical file there was record format that we mentioned using R, the record label. That is record format that contains the fields. So in case of logical file, we can define that record label multiple times, 32 times. So maximum 32 times. So there we can have multiple record format for multiple purpose. Okay, so all the each of the record format can refer to multiple PF or single PF. Okay, so that is for non-join logical file. When a logical file is like referring to one or more physical file, it is not combining the physical files. There is another type, that is join logical file. Okay. Join logical file is like it will be combining multiple physical file based on common field. Maybe you have learned SQL joins in your academics. So if any of you know of that, that can be done using logical file inside our sorry IBMI. Okay, so we'll see how the logical file DDS is created. Okay, So we remember that in PF we mentioned file level, record level, field level, and key field level, those keywords. Here in logical file, those will be common for a non-join logical file, but there will be one optional level that we call it select omit level. That is to like filter out the data based on some condition. Okay, this is one additional level here. Those are optional. Okay. So file level is also optional here. Record level is mandatory because you need to mention one record format name as well as you need to mention which physical file it is referring to. And field level, you can, it is also optional. If you mentioning the record format name same as the physical file, you don't need to mention any field there. Um, you can mention if you want to filter out few of the fields from that physical file. And key field level is like to define the keys. So if any key is there in the physical file, you can define another key here. You can define multiple key fields here. Okay. So we'll see one example how the DDS is created. So let us go to the session again. All right. So for the students file, this is the student files. You can see roll number, first name, last name, gender, date of birth, address, phone, all of these are there. Key field is roll number. I want to see the data based on first name. So I can create one LF. Okay. DDS. So here I am giving the record format name same as the physical file record format name, that was stdfr. So here, as we mentioned this, all the fields of inside this record format will be present in this logical file as well, because we are referring to all the fields from that physical file. Okay. So by default, this logical file will have fields same as the physical file because we are mentioning a record format name. We are not mentioning anything on the field level. After record format level, there is field level, as you know. So we are not mentioning it here. On the record format level, we can mention this. We need to mention this mandatory keyword p file. That p file will contain the physical file name. We need to mention a physical file name, that is students. We can give the library name as well. Here we can mention the library name. We can hard code it here. Suppose we want to mention the library name as well. If you want to mention the particular library, you can always hard code it here PIUINT, and you can give the library name. So this will refer to this physical file from this particular library. Okay, for now, let's not mention the library name. Let's see what happens. So here, this is the record label. The optional file label I haven't mentioned here, record level, and this is the key field level. So let us compile this. To compile, we can take 14 option. If you take F4 here, you will see that the command behind the compilation is crtlf. So here it is referring to this physical file. I mean to the source of student telephone inside QKNAKSRC. See, once I hit the enter, the student telephone will be created inside PIOINT library. It will refer to student LF1 source. So it is created. Okay. So I have created the object. So will this object contain data? So let us see if it contains data or not. If we check this, it is showing data, but the fact is it does not contain data. It is showing data because it refers to the refers to that physical file. It is showing that um, data of that physical file because it is referring to that physical file. It is a view of that physical file. It does not contain the data. It is containing the constant of that, like how you want to display the data. All right. So as you saw that we mentioned fname as the key. So what will happen if we do upddta on that student LF1? You can see that it is arranged on first name order. Previously for the physical file, it was arranged using roll number. But right now you can see this name starting with A. So this is in the ascending order. By default, it is ascending order as we did not mention descent on the fname key field. So it will be arranged in the ascending order. A, H, R, S. So in this order, it is arranged. So if you do not remember, so we'll show you that for few, so the physical file also, you can see it is arranged in the roll number order, roll number 1, 2, 3, 4, and so on. So, but for the logical file, it is arranged in the first name order. And also we can insert record using this logical file. Okay, let's just try to insert. We can take F10 here. Suppose I'm inserting some name starting with M, Mohit S. Mohit, and the roll number, suppose I'm giving 5 here. Alright, last name S, gender M, date of birth 2002, 0301, 2002, 0203, and here address I'm giving some random XYZ, and contact number. So here it is showing that record is inserted in this order, but record will not be inserted in this order. Record will be inserted inside the physical file. Okay, so here we are showing it in this order only. So once we hit enter here, the record is added. Let's see if we see the update data student LF1, how it is displayed. Ankita, Himanshu, H, M has come here because it is in alphabetical order for the first name, and it is displayed like this. Okay, but if you see the physical file, update data students, here you will see on the roll number order, so the M will come, the new record I inserted, that will come at last of this, Mohit. So I hope you got some idea about this, how the key field is implemented here and how it impacts the data. All right. So here, if I take another example, we mentioned that using logical file, we can rearrange or arrange the sequence of the fields in a different order. So here you can see that here it is first name I put first, then last name, then full name, then gender. So it is sequenced in different order. And here we can do concatenate two fields. So this concat keyword, this will implement the concatenation of first name and last name. So let's see if we compile this, and you can see here we gave the record format different here. It is not matching with the physical file. And I am giving the key field is a concatenated field. So these all things we can do here. So what will happen if we compile this one? So let's see how the data is displayed for this one. So you can see that name is concatenated. All right, and the order is also like this. In the sequence we put in the new LF, that will be on that order. All right, so if you want to update the data of this UP DDTA of this file, okay, you will see it is showing full name. So based on the length, you will insert record through this, but based on the DDS of PF, it will break the fields in such way for the field and for the concatenated field, and it will insert the record there, right? And whatever field you haven't mentioned here, that will take the default value. So this way you can use the PFs, logical files you can create and compile it. There is another level we mentioned, that is select and omit level. Here, that will is to filter out the data. All right, so let us see one example of that selected omit. So suppose this is one physical file. Okay, item file 1, which contains this data. All right, so item name, sold amount, and sold date and all, and remaining amount, how much remaining amount is there. Suppose I want to filter the data in a specific manner. So in that case, I can create one logical file that will contain like this. We can give the select condition here. So amount, whatever amount is greater than 2000, that will be selected. Okay, if you see the DDS here, so select level, we are giving this. So if we compile the, okay, I think it was okay, we'll replace it again. So if we compile this LF1, let's see how the data is displayed. So it is selecting only those records where the sold amount is greater than 5,000. All right. We can have omit level as well. All right. The example is like I want to omit the records. Omit means skipping the records. I am not selecting the records. Those are equals to 0, where the stock is 0 and where the amount is greater than 2000. So you can see the data of this file one, how the data was there. It was like this way. So I don't want to include this, and I want to select only those which are greater than 2000. So 9000, 8000, and 5000 will be selected. So let's see, using L2, you can see that only those records that are applicable for amount greater than sold amount 5000, 2000, and not remaining amount is not 0, those are selected here. So this is the use of select and omit level. All right. Okay. So all the levels are explained here. So you can try examples of these, like we mentioned few example previously. Here also we can mention those keywords and we can try out examples. All right. So let's move to the next slide. So we already covered this one, CRTLF. When you compile using 14 option, the command behind the compilation is CRTLF to compile the logical file. During the session of physical file, we learned the DSP, FD, DSP, FFD that will show the fields of the logical physical file. So in case of logical file also it is applicable. So suppose I right now created this one logical file. So let's see what DSPFD shows for this. DSPFD is logical file. So you can see that this is one type of logical file. Here, the important thing we can know of this command is we can know that what file it is based on, the physical file it is based on, and in what library it is there, and what is the record format of that, and how many number of fields are there. Everything you can see, and you can see the select omit level as well. Compare this. And if you want to see the L2, here also you will see DSPFD. You will see all the information there. All right, same way. And what will happen if we have some like different record format? So you saw that we created this one using different record format. So what will happen for this? We added different record format and we added new field as well. So let's check for this one what DSP FFD is showing, this display field description. So here you will see that the fields that are mentioned inside that logical file, those are only displayed here because we mentioned the different record format. All right. But for the LF1, you will see that it is showing all the fields of that physical file. Okay. So this was DSP BFD and DSP FFD. You can run of it. And to know that one physical file is having how many LFs. Okay. In that case, you can check using DSP DBR, display database relation. Using that, you can see, suppose my S item F1, this physical file is having two LFs. Okay, one for selecting only this amount greater than 2000. One was for selecting amount greater than 2000 and omitting the stock amount that is equal to 0. So these are having two logical files. So let's see DSP DVR on that physical file. What does it show? It is showing that site LM2, site LM1. Okay. So here you can see I am not mentioning the library name. So from where it is referring from the library list. Let's suppose I am removing this PIOINT from this library. Okay, from the library list. So what will happen if I check this DSP FFD or DSP DVR? So it is not getting the file name because file system This is not found in the star libl. We can always hard code the library name here. If we hard code it, it will pick that file from that particular library. It will show it. If we don't hard code, it will take from library list. Okay. Another thing you can remember, you can keep in mind that one, if a file is created inside a library, you cannot create another file with the same name inside the library, but you can always create the same file in different library. Okay, that we'll learn later when we practice it. So here library concept is important because when we create one logical file, suppose take one example, EDTLIPL, I did not mention the library name here. I am trying to compile this or create this logical file. All right. This logical file, I haven't mentioned library here. Always you can mention the library name in the P file. Here I haven't mentioned the library name. So I want to compile this. I already compiled. So let me delete that object. All right. LM1. Okay. I'll delete the object from that particular library, PIOINT. So I'll delete using 4. The command behind 4 is DLT file. Okay, the object file is deleted. Now I want to create this logical file. Okay, it is throwing me error in DDS. Why it is throwing error? You can always check full file to check here the error. So, so, the, so here while compiling it, so it is not getting the physical file. Okay, so that's why it is throwing the error because my physical file is not inside the library list. Okay, so here you can check using works full file, you can check all the information why my compilation failed. Okay, here it is given file specified on queue are not found. So in the P file option, I mentioned the file name. It is trying to find the file name inside my library list, but inside my library list there is no edit there is no file named item pf inside these libraries. It is residing inside PIOINT. So it is not compiled. What will happen if I hard code this here? Okay, insert PIOINT. Let's see, because I'm hard coding the library. Will it create? It is created because I have hard coded the library. So every time you are creating a LF, make sure that PF is present inside your library, and in the same library you are creating the PF. The PF resides. You need to create the LF in the same library. So that is the good practice, or else your LF will not be compiled. So during when we learned about the PF, we saw that if we compile the physical file, the data is lost because physical file contains data. When we are compiling it, the object is deleted and again created. The object contains the data. That's why the physical file, the data is lost. But you can see every time I'm compiling this logical file, is the data lost? Let us see, because right now we compiled this one. So let us see. Let us compile it again. Okay. I'm replacing the object, so it is compiled. The file is created there. Let us see if the data is lost or not. Okay, you need to mention the library name because library is not present in the library list, PIOINT. So you can see data is there because as we mentioned in the very first slide of LF, that LF does not contain data, PF contains data. It is just referring that PF to display the data. So that way we can, whenever we're creating LF, so the data is not lost. Let us see when we try to delete this physical file, what will happen? We can always delete this physical file, right? Work object. Okay, my library is not, library list is not set. So let us see PIOINT I'm mentioning here. I'm trying to delete this object using delete object. It is not deleted. Why it is not deleted? Because it has some dependent logical files. So this concept you can remember, that will that will be useful later. Okay, So we have only one topic left. So this is about join logical file. It was we mentioned that logical file have of two types, non-join and join. This join logical file concept, this was used previously in old days, but right now we mainly prefer SQLs to handle the files. But you can learn about this. I'll just give you a brief overview of this join logical file. When we are combining two physical files using based on one common field, we call it join logical file. By default, it is intersection type. You may be learned in SQL that if it is there is a common field, we can always combine two logical files. I mean two tables using one common field. So it has some different levels: file level, record level. Here on additional level is their join level, and also we have field level, also key field level and select omit level. Those are optional, but we need to mention the key level. The mandatory one is here, the join level, okay, and record level. So let us see one example of join logical file. So we have two physical files. One is employee master file that contains data of employee, mm, that is ID, name and DOB, and one is address file that contains ID, name, address and phone. Using join logical file, we can combine these two. There are some mandatory keywords like J file. We're combining these two physical file, and here we are joining first one and second one. As we can join multiple physical files, in this example we are showing only two physical files, and based on the field ID, both of the file are having ID as common field, and this ID is referring to first file, this ID is referring to first file, and we are having these fields there. So let us see, once we create this one, how the data is displayed. Okay, in employee master file we can see the data is like run query. Employee master file is having, okay, let me add the library PIOINT. Okay, the employee master file, you can see the data is like this: ID, name and date of birth. On the employee address file, we can see the data as this: name, address and phone number. So if we create this join logical file, okay, it was already created, I'll replace this. So let us see, using this join logical file, how the data is displayed. You can see that it is displayed. It has combined both of that based on the employee ID, and all the fields of both the files which we selected, those are displayed here. So this is the example of join logical file, and you can use these to join two files. So these were all about the logical file, and there is no more slides left, so you can ask questions if you have. For different members of same physical file, the object is created differently in the same, okay, you know, to okay, the object of the physical file is, okay, same only. We are adding member to that. Okay, object is created while we compile the physical file source. When you are adding member, there it is adding new member to that object is already created. Okay, as logical error is known as view of data of PF, how can it? Yeah, it is related to the PF, that PF, so we can add, delete, update record through that logical file. Yes, whenever we perform those operations on a PF also, add, delete, insert. It checks all the LFs, dependent LFs, what all constraints are there. If all the constraints match, in that case only it will allow the data insertion. Same goes for the LF also. If you are adding the record through the LF, it is actually adding record to the PF, so it will check all the constraints and it will insert the record based on that if all the constant match. All right. Also, if you have more questions, you can always ask it on the links given. Okay. On the YouTube live also, we'll respond to that. Okay, so our time is over. So we'll stop the session here. Thank you everyone for joining. Have a great day.